Welcome, listeners. Have you ever wondered what makes those super bright lights in stadiums and streetlights or big warehouses work? We're talking about HID lamps. That stands for High-Intensity Discharge. They're amazing at putting out a lot of light, but they need a special friend to help them out, something called a ballast. Think of a ballast like a traffic cop for your HID light bulb. It's a crucial part, and today we're going to break down what it does in simple terms. Imagine your light bulb is a tiny, hungry monster. When you first turn it on, it wants to gobble up all the electricity it can get really fast. If it did that, it would basically explode. That's where the ballast steps in. First, the ballast gives the lamp a perfect little jolt to get it going. It's like giving a car a jump start. Just enough power to get the engine turning over. It provides the right starting current and the right starting voltage. Without this precise kick, the lamp just wouldn't light up. Now, once the lamp starts, it's like a runaway train. It wants to pull in more and more electricity, which is a big problem. The ballast's second job is to control the current. This is perhaps the most basic, but the most important job. The ballast acts like a gatekeeper, limiting the flow of electricity to the lamp. If it didn't do this, the lamp would draw so much power that it would overheat and you guessed it, literally explode. So the ballast protects the lamp from itself, letting just the right amount of electricity through so it can glow brightly without self-destructing. Sometimes, the regular wall outlet power isn't enough to get those powerful lamps started. That brings us to the third job of the ballast, and that's being the voltage booster. Think of the ballast as also being a voltage transformer. Let's say your house electricity is at 120 volts, but your HID lamp needs 240 volts to get started. The ballast can magically take the 120 volts and step it up to 240 volts needed. It does this using coils of wire inside, similar to how a bicycle chain with different sized gears can change how much effort is needed to the pedal. More turns on one side, more voltage on the other. And for some really specific lamps, like high pressure sodium lamps, it even provides a quick, powerful burst of high voltage, a tiny electrical spike, to get them ignited. It's like a quick, strong tap to wake them up. Once the lamp is on and glowing, it needs to be kept happy and stable. HID lamps, after they have been on for a few minutes, settle into a comfortable operating rhythm. But sometimes the electricity coming from your wall can fluctuate a bit, like waves on the ocean. If that happened, the lamp's brightness and how much power it uses would jump all over the place. The ballast steps in to regulate the flow of current and act as a shock absorber. It takes those wobbly voltage inputs and smooths them out, making sure the lamp gets a constant, steady supply of power. Here's a cool trick some ballasts do. Imagine the ballast has a brain made of steel. If the incoming electricity sometimes gets too high, the steel brain gets overworked magnetically. When that happens, it cleverly decides not to pass all that extra voltage to the lamp. It essentially says, "Nope, lamp, you only get this much." This clever design helps the lamp stay perfectly stable, no matter what the power supply tries to throw at it. It's like having a dedicated filter just for your lamp. Now let's talk about something a little more technical, but still important. Power factor. Don't let the name scare you. Think of power as doing useful work. When you're running an HID lamp with a ballast, not all the electricity is actually used to make light. Some of it is just circulating, doing nothing useful. This is where the power factor comes in. Imagine you're trying to push a car. If you're pushing directly from behind, all your effort goes into moving the car forward. That's a high power factor, very efficient. But if you're pushing from the side, some of your effort is wasted, not pushing the car forward. That's a low power factor, less efficient. A normal power factor ballast is a bit less efficient. It might need more than twice the electricity just to get the same amount of useful light as a regular light bulb. This is usually okay for smaller lamps. But a high power factor ballast is super efficient. It means almost all the electricity it draws is actually used to make light. This is great for big installations, like many streetlights, because you can connect a lot more lamps to the same electrical circuit without overloading it. It's like being able to push many more cars at once without getting tired. Here's a simple way to remember it. A high power factor means less wasted electricity and more light for your buck. Beyond these main jobs, ballasts also have a few other characteristics to keep in mind. Ballast efficiency. No ballast is perfect. Some electricity always gets lost to heat. A 90% efficient ballast means 10% of the power is wasted as heat, not light. Line voltage and regulation. Electricity from the wall can vary. Good ballasts are designed to handle these ups and downs, typically within a certain percentage, so your light doesn't flicker or die. Extinction voltage. Sometimes the power dips suddenly, like a quick blackout. A good ballast should be able to ride out these dips without the lamp going completely dark. Let's quickly look at some types of ballasts. Reactor ballasts. These are the simplest. Think of them as just a basic current limiter. They are good for certain situations, but not super fancy with voltage regulation. Next, we have the high-reactance ballasts. A step up from reactors, these can also transform voltage. They are common for mercury vapor and high-pressure sodium lamps. And finally, we have constant wattage autotransformer ballasts, or CWA ballasts. These are the smart ones. They are really good at keeping the lamp power stable even if the wall voltage fluctuates a lot. They are also always high power factor, making them very efficient. You'll find these in big lighting setups like sports arenas. A super important tip for remembering all this: always match your lamp with your ballast. If you put a lamp that needs, say, 100 volts into a fixture with a ballast designed for 50-volt lamp, the lamp will be really dim. Or worse, if the lamp is too small for the ballast, it can drastically shorten the lamp life. Always check the wattage and voltage ratings to make sure they're a perfect match. So, the next time you see a super bright HID light, remember its unsung hero, the ballast. It's a traffic cop, a voltage booster, a current catcher, and the efficiency expert, all rolled into one, making sure those powerful lights shine brightly and safely. Thanks for listening.